Hello students, in this video we are going to study about the terms associated with spherical lens. The first term is aperture. As you can see, I have written the diameter of the circular edge of the lens is called as aperture. I have drawn two diagrams of lens, one of convex lens and one of concave lens. And in that, point A and B is being marked. These 2 points and the line which is passing through it is known as aperture. It tells about the size of the lens. The second term is the optical center. Optical center is represented by capital O, and in the diagram you may see that the center point is marked as O. In mirror, if you remember, this center point of the mirror was known as pole, which was represented by capital P. But here, in case of lens, we represent that same central point as O, capital O. Any line which or any ray which passes with optical center does not deviate anywhere. That means it is that point which plays the same role as we have seen it in case of mirror plays the center curvature. So, from the optical center, if a ray is passed, it does not deviate anywhere and all the distances will be measured from this point only. The next point is center of curvature. It is represented by capital C1 and C2 or 2F1 and 2F2. The thing that you have to keep in mind here is that in case of lens, we do not have only one center of curvature. Instead, we have two center of curvature, one on the either side, and therefore it is written center of curvatures. Representation can be given with C1 with the letter C, or it can also be denoted by 2F, because the center of curvature, as we have read it in the mirror, in case of mirror, that this distance is twice the distance of the focal length. So, we can write it as 2F1 or 2F2 or C1 and C2. Whichever one you feel it's good or comfortable for you, easy for you, you can opt any one of the notation. These centers are actually belonging to the centers of that particular solid sphere from which the spherical lens is made, and they are being situated at double the distance of the principal focus. The next point is principal focus. It is represented by capital F1 and F2. It is a point on principal axis such that the rays parallel to principal axis after refraction meet at this particular point. Let me show you how this happens. Here you can see a convex lens, and when the parallel rays means they will be parallel to which particular thing? They will be parallel to the principal axis. So these incident rays, when they come parallel to the principal axis, after refraction they are going to bend. And where do they bend? They bend toward the focus. Since this is a convex lens whose another name is also converging lens, so it bends toward the focus F2. So this particular point is known as principal focus of a convex lens. So F2 is known as the principal focus of the convex lens. Similarly, for a concave lens, if a ray of light comes from here parallel to the principal axis, again another ray of light parallel to the principal axis, then after refraction it bends outward. Since this is a diverging lens, here also it bends outward as it is a diverging lens, and when we proceed these lines, imaginary lines, then they meet at this point which is known as F1. So this is the principal focus of the convex lens as well as the concave lens. The last point is the principal axis, and here the line that you can see which is passing from the center, it should pass from O and center of curvature, that is C or 2F. So if the line passes from these 2 points, then it is known as principal axis. All the distances will be, and all the calculation will be measured with respect to this particular line. With this, we finish the term associated with spherical lens. Thank you.